For page 2 of our Chapter 9 practice test, or our first review of it, let's go back to some variation. For number 6, the intensity of light, I. It says varies inversely, so we know we're going to have to divide. Say K divided by, but now we've got the square of the observer's distance, D. We have to be so careful. It's not just K divided by D, but K divided by D squared. The light intensity is 10 lumens. That's your I. So we have 10 is equal to K divided by, your distance is 3. So D is equal to 3 right here. I is equal to 10. That's the information you're going to plug in. Now 3 squared, of course, is 9. So this would become 10 equals K divided by 9. You could cross multiply if you'd like. 1 times K is K. 10 times 9 is 90. But the final answer that we're going to have, we need to put that K value back in. We'll have I is equal to 90 over D squared. Now for part B, what is the light intensity if the observer is 6 meters from the light source? Well, we're going to use the same formula, but now we've got a distance of 6 meters. So D is going to be 6. We're going to plug that in and see what we get. I is going to be 90 divided by 6 squared. Tell you what, we could get our calculator out, get a fraction going here, and very quickly type in 90. Down here we can type in 6 to the second power, which of course we know is 36, but we'd get 5 halves, 5 over 2. Or if you just used the slash dividing without the fraction tool, you'd get 2.5. But I is equal to 2.5, that's 2.5 lumens, and we are done. Let's take a look at our second problem here on the page, the last problem on this page. Whenever we have a graph of a rational function, we have to be very much aware that there are two numbers that we need to be paying attention to. One is the number down below by the x. And we've talked so much about X-Files, how that was a very strange TV show and movie. It looks like -3 is associated with x, but we're going to use reverse logic and say x is really +3. That's your vertical asymptote, x equals 3. Your domain is going to be such that x cannot be equal to 3. Now we can, at this point, go over to x is equal to 3 and draw in a vertical dashed line. At some point you're going to have to do that. You might as well do that right now. That's a very important part of the graph, and it is required. Well, we also have a +0 here. And with that +0, that's going to be associated with your horizontal asymptote. You'd say y equals 0. Your range would be such that y could not equal 0. And please draw in, even though that is going over the x-axis, we do want to see that horizontal asymptote drawn in. And right now, you are almost done when it comes to finishing this thing up. The calculator is going to come to your rescue right now. We can go to y equals, and without too much work, we can get a fraction, alpha y equals, and type in 4 all over x minus 3. I'm going to hit the right arrow. It is not necessary to say +0. You may if you want. Of course, that's kind of silly. But what we have been doing in class is we'd hit math and come down here to decimal. And this will convert that value always into a decimal, which when we use our table, that could be very, very, very helpful. Here's where we're going, though. Let's go to second table. And really, we would expect for us to have a problem at x equals 3. You can see we do. That's where we have an error. But if you were to go 2 steps smaller than your error and 2 steps larger, you're going to be able to get some very helpful information. You'll see at 1 you'll be at -2, at 2 you'll be at -4, at 4 we will be at 4, and you can see at 5 we're actually going to be at 2. Now I'm going to change a color over here and really just help us draw in this graph, hopefully with a different color, and make it stand out a little bit more. So 1 comma -2 will go 1 to the right, go down 2 steps. 2 to the right will go down 4, 1, 2, 3, 4. 4 to the right will go 1, 2, 3, 4. We can go up 4 steps, 1, 2, 3, 4. And then 5 to the right will just go up 2. Now right here you can begin to have a pretty good idea as to what this thing is looking like. If you were to hit graph, you get that general shape, and that definitely is going to help you out. You always get that hyperbola shape. If you want to, you can also get extra points. You can see at -1 would be at -1. That's not a bad thing to do, especially if your graph looks a little bit more spread out. You can arrow down a little bit, just looking for some friendly points if you ever see them. You can see at 7 comma 1, be at 1, 2, 3, 4, 5, 6, 7. That's right up here. Why might that be helpful? Well, it can add in some detail as to that graph. But you already know what this general shape would look like. And just connecting these, now you have a very detailed and good graph.